A Summary of the Depolarization of a Neuron by Luis Gonzalez, Ethan Mendoza, and Liam Augustyn.
The depolarization of a neuron occurs when the inside of a neuron cell undergoes a sudden shift in electrical charge. In the case of a neuron, the inside of the cell drastically changes from negative to positive. This drastic change slowly reverts once the action potential occurs. The depolarization of a neuron is essential for the transmission of stimulus between neurons or within a neuron. The depolarization of a neuron begins when a stimulus causes a change in the neuron. Once this reaches the axon, it creates an action potential, a small period where the charge of the neuron rises significantly, then falls. The outside of the neuron contains an abundance of sodium ions, while the inside has many potassium. The stimulus causes the sodium pumps to open, allowing the sodium ions to flow into the neuron. This changes the charge in the neuron to be slightly less negative. Once the charge is changed enough, the neuron reaches a certain threshold which causes more sodium pumps to open, allowing even more sodium ions into the cell. The slight change in charge slowly affects the next bunch of sodium pumps. This effect occurs like a wave down through the neuron. The shift in electrical charge jumps from node to node, increasing the rate at which stimuli is transferred. Eventually, so many sodium ions are transferred into the neuron that the charges flip. The inside becomes positive and the outside becomes negative. Neurons want to change this, so the sodium channels close and the potassium pumps open. The potassium flows towards the outside of the neuron and the charge reverts to its original state. However, the potassium and sodium ions lie on opposite sides at this point. This is where the sodium-potassium pumps come into play. The pumps moves 3 sodium ions to the outside and 2 potassium to the inside for the cost of 1 ATP. Once the pump has completed its job, the neuron reaches its resting potential.